All right, so proofs with segment relationships. There's a couple things that I can fill in before I have to start thinking too hard. What goes right here in the first statement box? QT is congruent to RV, yes. QT is congruent to RV. And why are we allowed to make that statement? What would my reason for that be? It's given. All right, I've got one more thing that I can fill in without thinking too hard. What goes in the very bottom statement box? QR is congruent to TV goes down here. Segment QR is congruent to segment TV. Do I know the reason for that yet? No. I won't know the reason for that last step until I know what statement 5 is. I have to know what the statement right before it is because I have to see what changes between statement 5 and statement 6. That'll tell me what's going on over here. Is prove ever a reason? No. Prove is what we are doing. Prove is the action verb here. All right. So let's look at this picture here. We know that QT, this is QT, is congruent to RV, this segment right here. So QT, this whole thing right here, is the same size as RV, this piece right here. Do those two segments share anything? They share RT. What we're trying to prove in the end is that QR, this little segment right here, and TV, this little segment back here, are the same size. So it looks like I'm going to be able to show that if I can just take away this section that they share, that's part of both of them. What operation lets me take things away in math? Subtraction. Can I use subtraction with a congruence sign? No. If I'm going to use adding, subtracting, multiplying, or dividing, I have to have what kind of a symbol? I have to have an equal sign. So I'm going to come over here. Since I know I'm going to need an equal sign so I can subtract, I'm going to rewrite statement 1, but with an equal sign. And that means that I'm going to leave off the segment notation. So instead of saying segment QT is congruent to segment RV, I'm going to say the length of segment QT is equal to the length of segment RV. Why would I be allowed to say that? We knew in statement 1 that they were congruent segments. Now I'm saying that means they have the same length. Why would I be allowed to say that? What did you say? If they're congruent, they have the same measurement. Look on the red paper. That's exactly what we're looking for. Why are we allowed to make that statement? What reason are we using? You're absolutely right in your reasoning, but we have to come up with just a couple words that encompasses that idea. I heard definition of congruent segments. If two segments are congruent, then that means they have the same measurements. If they have the same measurements, then that means they are congruent. So we are using the definition of congruent segments. Beautiful. Beautiful, beautiful, beautiful. All right. QT, this segment right here, is made up of two smaller segments put together. What are the two smaller segments that have been put together to make QT? QR and RT. So QR plus RT equals QT. Can I make a similar statement about RV? Is RV made up of two smaller segments? RT and TV. RT plus TV equals RV. Now this statement right here that I made in statement 3, we wrote two equations. I could have written this at any point in time. It didn't have to wait until statement 3. I even could have said this first. This does not rely on my given information. This relies on the picture. What reason from the red paper can we use to say that two smaller segments add together to give me a bigger segment? What reason from the red paper can we use to say that two smaller segments added together? Close. It is addition something. Addition property of equality. I would have to start off with an equal sign like here in step 2, and then you would have to see the same thing added to both sides in the next step. Segment addition postulate, yes. Segment addition postulate. The segment addition postulate is what lets me take two smaller segments and add them together to get a bigger segment. All right. We're getting there. Remember, the whole goal, why we're doing this, we want just QR and just TV left at the end, which we said means I need to get rid of RT from both of them. Well, we are going to take this side of the equal sign, QR plus RT, because that has the RT that I want to take away. It's going to replace QT right here. QR plus RT took the place of QT because they were equal in size. What can I replace RV with? RT plus TV. RT plus TV, this piece right here, takes the place of RV. So RT plus TV. Why would I be allowed to take something out of an equation but replace it with something that's the same size? Substitution, yes. That is the substitution property. All right. I've almost got what I want. Here's QR. Here's QR. Here's TV. Here's TV. So I have QR on the left. I have TV on the right. Yes. We want to get rid of the RT on both sides, so we're going to use subtraction. So if I subtract RT from both sides, I would have QR equals TV, using the subtraction property of equality. Subtraction property of equality. All right. Last reason. We have all of our statements written. When I look at statement 5, it looks almost like statement 6. What's the difference between statement 5 and statement 6? There's a congruence symbol now. What else is different? Yeah, we've got that segment notation down here. Here we're talking about the lengths of the segments being equal. And here we're talking about the segments being congruent. Why would I be allowed, if I know that the two segments have the same length, why would I be allowed to then make this jump and say that means they are congruent? I know the segments have the same length. Why am I allowed to say that means they are congruent? It's not my transitive property. Definition of something, yes. Definition of what? What are we talking about here? Congruent segments. Definition of congruent segments. We already used definition of congruent segments once in this proof, didn't we? We can use the same reason more than one time in a proof. We can use it as many times as we want if it makes sense. Up here, we knew they were congruent, and we used definition of congruent segments to say that means they have the same length. Here, we knew they had the same length, and we used definition of congruent segments to say that means they are congruent. All right, let's go do number 2 now. Number 2 now. What goes here? Perfect. All of this right here comes down to my statement box. R is the midpoint of QS T is the midpoint of VS segment QR is congruent to segment VT. What's the reason for all 3 of those statements that are all crammed into the same box? Given. I need you to put your phone away, please. There's another statement that I can make without really thinking too much. What is it? Yes, segment RS is congruent to segment TS. Do we know why we can make that statement yet? Nope, not yet. Not quite sure why. Alrighty. So let's use this given information now. It says R is the midpoint of QS. Well, if I know that R is the midpoint of QS, what else can I say about this? QR and RS, they are congruent. I could say that. It's going to add an extra step to my proof. Or I can say that they are equal. If I say they're congruent, I'm using midpoint theorem. If I say they're equal, what are we using? Definition of midpoint, yes. QR is equal to RS. Could I say something similar about the other midpoint that we know about? Yes, and VT is equal to TS. What are we using to be able to say that again? Definition of midpoint. All right. Thank you. There was a third thing in my given information that we haven't used yet that I'd like to use now. If I know that 2 segments are congruent, then what else can I say about them? If I know that 2 segments are congruent, then what else can I say about them? They're equal. So the length of segment QR is equal to the length of segment VT. What did we just use? Didn't use midpoint this time because on this part, I didn't know about a midpoint. I didn't use substitution. Look, this stayed the same, except it lost the bar over the top. This stayed the same, except it lost the bar over the top. And this symbol, the congruent symbol, changed to an equal sign. Definition of congruent segments. Definition of congruent segments. All right, let's look at where we're trying to get to. What do I want in the end on the left? I want RS. Right now I have QR. Do I know something that's the same size as QR? RS. So I can make this replacement. I can write RS instead of QR. Do I know anything that's the same size as VT? TS. So I can replace VT with TS. Why am I allowed to make replacements like this? Substitution. That is my substitution property. All right. Last reason. Statement 4 and statement 5 look almost identical, right? What's the difference between statement 4 and statement 5? One's congruent, the other one is equal. Here I'm saying that these two segments have the same length. Down here I'm saying that means they're congruent. What are we using? Definition of congruent segments again, yes. Definition of congruent segments. All right, nice work. Let's flip over to page 14 and do one last proof. And then we'll be done for the day. What goes here? The given information, yes. So I don't write given in that box. I write CE is congruent to FE. Segment CE is congruent to segment FE. And segment ED is congruent to segment EG. Why are we allowed to make those statements? Because it's given. What else can I fill in without really thinking? Segment CD is congruent to segment FG, and that goes all the way down in my bottom box. My last statement. Don't know the reason for that yet. Won't know the reason until I get statement 6. All right, so let's look at what they've actually given us. We know that segment CE, this little segment right here, is congruent to segment FE right here. And then we also know that segment ED, this segment right here, is congruent to segment EG, this one right here. At the end, we want to talk about segment CD and segment FG. Well, segment CD is made up of two smaller segments put together, right? Same thing over here for segment FG. That's two smaller segments put together. What operation am I going to have to use if I'm putting things together? I'm going to have to use addition. Can I use addition with congruent signs? No. So we're going to have to rewrite statement 1, but with equal signs instead of congruent signs. So the length of segment CE is equal to the length of segment FE, and the length of segment ED is equal to the length of segment EG. Why am I allowed to say that? Didn't make any substitutions. I still have CE, CE, FE, FE, ED, ED, EG, EG. No substitutions happened. Yes, definition of congruent segments. Beautiful. Beautiful, beautiful. All right, I'm going to do something kind of weird now. We said we're going to have to do some addition, right? I'm going to use this equation right here, and I'm going to add the same thing to both sides. I'm going to add the exact same thing to both sides. So here's CE. I want to put that together with ED. So CE plus ED equals FE plus ED. Notice I added the exact same thing to both sides. What property lets me add the same thing to both sides? What property lets me add the same thing to both sides? What'd you say? The addition property of equality. Addition property of equality. All right. This is a little bit weird. So CE and ED together make that whole big long segment, right? But FE and ED don't make anything really. That doesn't make any sense. I don't get a bigger segment from those two. There's a bend in it. Do I know something that's the same size as ED? Same size as ED. EG. I'm going to take EG and replace ED with EG. So I have CE plus ED equals FE plus EG. I just replaced something. What property am I using if I make a replacement? Substitution. Bless you. Substitution property. All right. When I take CE and ED and put them together, CE is here, ED is here. When I put those two smaller segments together, what's the bigger segment that I get? CD. So CE plus ED equals CD. Can I say something similar about FE and EG? FE together with EG gives me what larger segment? FG. FE plus EG gives me FG. This statement right here, I am making solely based on the picture. I'm taking two smaller segments, putting them together, and getting a bigger segment. What property am I using when I add two smaller segments together and I get a bigger segment? What property are we using? That's when I add the exact same thing to both sides. Here I have two smaller segments being added together to give me a bigger segment. Segment addition postulate. Segment addition postulate. Nicely done. We're almost there. We got one more statement to make. All right. So instead of having CE plus ED here in step 4, what do I know that's the same size as that? What's the same size as CE plus ED? CD, yes. So this is going to take the place of CE plus ED. I have CD equals. What do I know of that's the same size as FE plus EG? FG. What did we just use? Substitution, yes. Substitution property. All right, last statement. Perfect definition of congruent segments. Fantastic. New homework is due on Thursday. New homework is due on Thursday. Have a great rest of your day, guys. I'll see you tomorrow.